So in this section, 2.3, we're going to talk about histograms. Yes, you heard me right, not Instagram, histogram. I'm going to say that one more time, histogram. And that's a special type of graph. Here's the proverb for this section. Blessed is the one who finds wisdom and the one who gets understanding, for the gain from her is better than gain from silver, and her profit better than gold. Wisdom, she is more precious than jewels, and nothing you desire can compare with her. In short words, or in short terms, understanding is the epitome of existence. When you understand the ins and outs of a particular field, of a particular topic or subject, that is what actually moves people and motivates people. When you understand the desires of your kids and how to wisely bring them up, or be it a business and how to make a profit, the wisdom is the most important thing. And so when we deal with this information, when we've gathered information, we've organized into a frequency distribution, we can glean information from that, and we can also present this visually as a histogram. And here's what that looks like as an example. A histogram is a graph consisting of bars of equal width drawn adjacent to each other. The height of each bar represents a frequency. So if you take a look at this, this is height of black cherry trees. So we have heights in feet. Between 60 and 65, we have 3 trees. Between 65 and 70, we have 3 trees. Between 70 and 75 inches tall, we have 8 trees. Okay, and so forth. So I can find the total number of trees by just adding up all of the columns here. Okay, and that's how I would be able to find out what's the total number of black cherry trees that were surveyed in this study. Notice that the horizontal axis is numeric, it's not categorical, and that is characteristic to a histogram. Okay, so here's some more examples. I'm going to just smother you with examples here. Quiz scores. So here is an example of side-by-side frequency distribution table, and then its corresponding histogram. So we have 5. All of this would be ungrouped data. So 5, 2 people got a 5 on the quiz. 3 people got a 4 on the quiz. 4 people got a 3, 2 got a 2, and 1 person got a 1 out of 5, it looks like, on the quiz. The histogram below shows children's heights. Please note that this symbol means that, look, notice we're not starting at 0. And a lot of times researchers would say, do this in their histograms to make sure they don't mislead you. Say that, please notice that there's a break and I'm starting a little bit later than you probably would assume. But this is a frequency distribution table of grouped data, right? 44 to 45, there was 1 person, and so forth, children's heights. You might imagine, it looks like this is a bimodal distribution. There, it looks like 2 most frequently occurring heights among children. Okay, so keep that in mind. There's distribution there. We also have 3-dimensional histograms. I just want to expose you guys to this. So I'm never going to make you guys create one. But in this case, Boston monthly temperature for a particular year and month. So there's years along this axis, there's months along this axis, and the height is the temperature. Okay. So 3-dimensional histograms. Normal distributions have bell-shaped histograms. You can see in this example there's a batting average, and the batting average is usually bell-shaped, right? And so you can see that the histograms follow that kind of a shape. Employees of cereal factory. So it looks like the average is around 10.2. So the average is going to be somewhere in the middle of the data set. And the standard deviation, we'll talk about that a little bit later, is 4.1 years. Okay? So normal distributions have histograms that are bell-shaped. And So here's some more. Normal distributions have histograms that are bell-shaped. If you do some photography, you've probably seen some histograms and dealt with them. If you want a perfect picture, you need more distribution, so a more bell-shaped curve. And if it is going to be skewed right or skewed left, more or less, then you're going to have either underexposure or overexposure of your picture that you're going to take. A lot of the digital cameras now account for this, and you could be able to manually decide which picture you would like. Here's a question. How much money do you think is in Brad Pitt's wallet? Try to guess right now. How much cash is in Brad Pitt's wallet at any given time? There was a survey done, and that survey brought about these results. Distribution of guesses of cash in Brad Pitt's wallet. I'm not sure how much you guessed, but most people guessed that he had around $500 in his pocket at any given time, right? So there is well over 140 people that thought that he carried $500, right? So histograms are used everywhere, and it looks like this one's bell-shaped as well. When we do surveys, we do them right. A lot of the surveys will end up being bell-shaped because people tend to decide on one of the values. Let's go a little bit deeper into this distribution idea. Here are terminology that I'll probably quiz you guys on. So a normal distribution or unimodal is a bell-shaped curve. There's one highest frequency class. If the tail end is on the right, then it'd be a skewed right distribution. The long tail's on the right. If the long tail's on the left, it is a skewed left distribution. And then we have a bimodal distribution where there are two modes, most frequently occurring values. And that's what it looks like. So this is something to remember, and now vocab to build to be able to refer to skewed right, skewed left, or normal distributions. Notice that the histogram and the relative frequency histogram have the same shape. So here we have pulse rate, beats per minute. And if we take a look at this, this is frequency here, right? Frequency, and then the pulse rate. How many people had a pulse rate between 59.5 and 69.5? Well, approximately 12, I would say, right? And notice now, if I take each one of these, add them all up, that would be the total number of data points that we would have, total number of pulse rates. And if you were going to take and find this, suppose it is 12, and divide it by the grand total that you just found, you'd get a cumulative frequency, 30%. And do the same thing for each one of these, and you get their respective percentages. So for the horizontal values, use the class boundaries or the class midpoints. There are some important characteristics of data that we're interested in. The acronym here is CV dot. C stands for center, a representative or average value that indicates where the middle of the data is located. We also have a sense of variation, a measure of the amount of that the values vary among themselves, or the data in how the data is dispersed, right? What's the largest, what's the smallest value? Take a difference between those two, and that would be your measure of variation. And what is the distribution? What is the visual shape that the graph has? Bell-shaped, uniform, skewed left, skewed right, and so forth. Outliers. Sometimes there are people that answer in a crazy way when you're taking a survey, and those are called outliers. So sample values that lie very far away from the vast majority of other sample values. And then time, changing the characteristics of data over time. If you change the characteristics, will the characteristics change if you do this experiment over or take the survey over again? Right? That's the question that pertains to the time in CV dot. So let's actually do this CV dot for this previous example. Our objective is not to just construct the histogram, but again to understand something about the data. So if you just eyeball it, at this point we don't have a calculation for the center. Let's eyeball it. Well, if you think about it, these act like weights. And so there's a very small amount of weight here. There's a lot of amount of weight to the left. And halfway between them would be something like 80. Very, very close right there. What is the variation? Well, we have the highest value would be 130 and lowest value would be 60. And so the variation actually would be between 60 and 130 beats per minute. What's the distribution? Distribution looks like to be the long tails on the right, so it's right skewed. There are some outliers. There was 125 beats per minute. That's the only outlier. That's pretty far away from the middle. And then T stands for time. Do we get the same results if we just measured again? And so that's what CV dot is about. So here is a chance for you guys to practice. Pause the video and create a histogram of the ages of the signers of the Declaration of Independence of the U.S. So please note just a couple of things. 27-year-olds. There are several 27-year-olds that signed the Declaration of Independence. I don't know how old you are, but just think about this. If you were 27 and you were basically deciding on the fate of an entire country, separating from Great Britain and England, and starting out creating laws and so forth, that is a lot of responsibility at the age of 27. But nonetheless, there were some of those. Some of them were lawyers, of course, that were very young. But go ahead and make a histogram. Pause the video, collect your data, put them in frequency distribution table. Under the frequencies, count them up, make the frequency distribution table, and then create the histogram based off of that table. Go ahead and pause the video and try it. Okay, there is a way to create a histogram on your calculator, and here is the way that you would do this. Go to step 1, choose stat plot, and choose stat plot just by pressing second and then the Y equals button in the upper left hand corner. Press enter, plot on, that should be on, cursor to type, cursor over to type and choose the histogram icon, and then press enter and you'll get a histogram. The second thing that you need to do is enter in the data. So you're going to press statistics, and then you're going to press the number 1, and you're going to edit L1, and that's where it's going to pull the data to be able to create a frequency distribution table and therefore create a histogram. You need to make sure that in order to see the bars that your window settings are set, and so here are some ways that will help. So the smallest x horizontal value is the first lower class limit, x scale is the class width, x max is the largest upper class limit, set y min, y max, -5, and a little higher than the largest frequency, and then press trace in the upper right hand corner, and you will be able to see your histogram that you've created. Awesome. So in this last section on 2.4, now we're going to talk about graphs. Just kidding. Graphs. You get it, right? There are a whole bunch of different graphs that we are going to take a look at to make sure you guys are exposed to many and how to read them. So let's go and check out the next video.